26 by looking at Part C of the reproductive system. So first let's talk about how the ovarian cycle is established. Well, during childhood, the ovaries grow, they secrete a small amount of estrogen, but that small amount of estrogen is actually going to inhibit the hypothalamic release of gonadotropin-releasing hormone. But as puberty nears, gonadotropin-releasing hormone will be released. It becomes less sensitive to that small amount of estrogen, and when gonadotropin-releasing hormone is released, it causes the release of the gonadotropins, follicle-stimulating hormone, and luteinizing hormone. They're released by the anterior pituitary. They're able to travel to the female gonads and act on those ovaries. And these events are just going to continue until an adult cyclic pattern in the first menstruation occurs called menarche. So the hormone interaction that produces the cyclic events in the ovarian cycle, so occurring at the ovaries, include gonadotropin-releasing hormone from the hypothalamus, the pituitary gonadotropins, follicle-stimulating hormone, and luteinizing hormone, and then ovarian estrogen and ovarian progesterone. And the onset of puberty is highly linked in females to the amount of adipose tissue via their ability to produce the hormone leptin. So during childhood until puberty, the ovaries are secreting small amounts of estrogen. We saw that was inhibiting the release of gonadotropin-releasing hormone. But if leptin levels are adequate as the female nears puberty, the hypothalamus becomes less sensitive to these small amounts of estrogen and is able to release gonadotropin-releasing hormone in a rhythmic pulse-like manner. After a while, that'll cause the release of the anterior pituitary follicle-stimulating hormone and luteinizing hormone, collectively called gonadotropins, and they'll travel in the blood to the ovaries and cause the release of ovarian hormones like progesterone and estrogen. So gonadotropin levels increase for about 4 years with no ovulation, no pregnancy possible, and then an adult cyclic pattern will be achieved, and it's when the adult cyclic pattern is achieved that menarche or the first menstrual period occurs. It's about 3 years before the cycle, even after menarche, is regular and all ovulatory. So let's go through that again, the hormonal interactions during the 28-day ovarian cycle. So gonadotropin-releasing hormone is released from the hypothalamus. That causes the release of follicle-stimulating hormone and luteinizing hormone from the anterior pituitary. Those gonadotropins are going to cause the release of ovarian estrogen and progesterone, but they're going to act on the follicles. First, cause the growth of several follicles, and it's follicular cells that actually start to release hormones, and that's why they're being able to cause the release of ovarian hormones. And it's this increase in plasma androgen or estrogen levels that inhibits the release of follicle-stimulating hormone and luteinizing hormone. So there is a negative feedback after we do get ovarian hormone release. So locally and briefly, there is an act on the nervous system by this increased estrogen that enhances further estrogen output. But we also have negative feedback aid from inhibin from the granulosa cells, so we are ultimately eventually going to be able to inhibit follicle-stimulating and luteinizing hormone release once there are adequate amounts of ovarian estrogen being released. When estrogen levels are high, we are getting a brief positive feedback on the brain and the anterior pituitary. That is that nervous system control that was brief that we talked about in the last slide. And that's going to cause a surge in gonadotropins about mid-cycle. So stored luteinizing hormone and a little bit of FSH or follicle-stimulating hormone are going to suddenly be released mid-cycle from the anterior pituitary, and it's actually the LH surge specifically, so a surge of luteinizing hormone that occurs mid-ovarian cycle that causes ovulation. The primary oocyte is going to be able to complete meiosis 1 to become a secondary oocyte because of this surge of LH. And it's the secondary oocyte that is ovulated and then, if fertilized, completes meiosis 2. So the LH or luteinizing hormone effects at mid-cycle include increases in local vascular permeability, inflammatory responses, which include metalloproteinase release, which is an enzyme that weakens the ovarian wall, so it's going to make it easier for the secondary oocyte to leave. It's going to stop blood flow, and it's going to stop blood flow to the protruding follicular wall. It causes this part of the ovary to almost kind of die. The wall thins, it helps the secondary oocyte bulge, and then ultimately allows rupture, or a hole to form, a stigma. And the oocyte with its corona radiata is able to exit, and that's ovulation. And this is aided again by luteinizing surge at mid-cycle. After ovulation, estrogen levels drop. Luteinizing hormone, though, stays around. It's going to be able to transform the ruptured follicle cells into the corpus luteum. So we'll leave the follicular growth stage of the ovarian cycle and enter into the luteal stage. It's LH that stimulates the corpus luteum to produce progesterone, a little bit of estrogen, but almost immediately, and the progesterone is going to help maintain the stratum functionalis and maintain pregnancy if it occurs. Again, negative feedback. Progesterone and estrogen levels will feed back to the anterior pituitary and inhibit the release of luteinizing hormone and follicle-stimulating hormone release. Inhibin helps out with that negative feedback, and that's from the corpus luteum or the granulosa cells. And declining LH does end luteal activity, so if no pregnancy occurs, LH activity will decline, and that'll cause corpus luteum activity to decline. It'll ultimately degenerate. So again, if no fertilization, the corpus luteum degenerates when the LH levels fall. The sharp decrease in estrogen and progesterone caused by corpus luteum degeneration will end the blockage of FSH and LH from the anterior pituitary and allows us to start all over with gonadotropin-releasing hormone leading to gonadotropin release from the anterior pituitary. And the oocyte actually is about activated 12 months prior to ovulation, not 14 days. So it takes a while for it to proceed throughout the rest of meiosis 1 and then 2. So let's look at the regulation of the ovarian cycle. First, we have gonadotropin releasing hormone from the hypothalamus going to the anterior pituitary and causing the release of the gonadotropins, FSH, follicle stimulating hormone, and LH, luteinizing hormone. Follicle stimulating hormone acts on follicles in the ovary, so it's going to aid or lead to follicular growth. And then luteinizing hormone is going to act on thecal cells of late secondary follicles and cause the production of androgens, which can be turned into or converted to estrogens by granulosa cells. This will cause an increase in plasma concentration of estrogen, which aids the maturation of vesicular follicles. It's vesicular follicles that will have a secondary oocyte ovulated from them, but don't forget that a rise in estrogen is actually able to inhibit further release of follicle-stimulating hormone and luteinizing hormone after ovulation. Inhibin also helps as well. Inhibin is produced by granulosa cells. Now, right before the negative inhibition of gonadotropins, there is a little bit of a positive feedback exerted by the large amount of estrogen that is being put out by the granulosa cells. And that large amount of estrogen is going to cause a mid-cycle surge of luteinizing hormone. So a little bit of follicle-stimulating hormone as well, but it's the luteinizing hormone, the LH surge, that leads to or causes the rupturing of the follicle or ovulation. So here we're seeing the ovulated secondary oocyte, and what's left behind are the ruptured follicular cells, and that's forming the corpus luteum. So after corpus luteum activity, we're going to see a rise in progesterone production. We'll see a little bit of a drop in estrogen, and if no pregnancy occurs, we'll see a drop in progesterone and the rest of the estrogen, and the cycle will start anew because we'll no longer have that inhibition of follicle-stimulating hormone and luteinizing hormone. But progesterone, estrogen, and inhibin right now are doing negative feedback, and until the corpus luteum degenerates, we will not have the cycle start anew. So you can see here in blue, the follicular phase, in green, the luteal phase of the ovarian cycle. And what we're also looking at is the correlation of anterior pituitary and ovarian hormones with the structural changes of the ovary and uterus. So more slides to come. This part is showing you the fluctuation of gonadotropin levels of the ovarian cycle. So mid-cycle between the follicular phase and the luteal phase, we see a surge in the gonadotropins, especially in luteinizing hormone. So it's the surge in LH that causes ovulation. So we can also see follicular growth here. We go from primordial to primary follicle, then secondary follicle, vesicular follicle, and it's the vesicular follicle that matures further and causes or participates in ovulation. Ovulation is ovulation of a secondary oocyte with its corona radiata. What's left behind and what we see in the luteal phase in green is the corpus luteum, which is degenerated or changed granulosa cells, which is a hormone-producing structure, mainly producing some estrogen, but mainly progesterone, and maybe even a little inhibin. And it will degenerate if there's no pregnancy. All right, we've looked at the ovarian cycle now in depth. We're going to look now at the menstrual or uterine cycle. So we're going to move away from the ovaries and talk about what is actually happening in the uterus. We talked about the 3 layers of the uterus, the endometrium, myometrium, and perimetrium. So we're going to focus now on the endometrium and kind of what's happening there. So the uterine cycle is cyclic changes in the endometrium in response to the fluctuating ovarian hormone levels. So there's 3 phases to the uterine cycle. The first phase is the menstrual phase. The second phase is the proliferative or pre-ovulatory phase. And the last phase is the secretory or post-ovulatory phase. So the post-ovulatory phase, the secretory phase, is going to be the most constant. It's 14 days in length. And so it matches up with the luteal phase of the ovarian cycle. Whereas the menstrual and proliferative phase together match up with what's going on during the follicular phase of the ovarian cycle. So let's look at the uterine cycle in more detail. So during the menstrual phase, ovarian hormones are at their lowest levels. This is when menstruation is occurring. The gonadotropins are just beginning to rise. They're just beginning to be released from the anterior pituitary. So during this phase, when the ovarian hormones are low, the stratum functionalis of the endometrium can be shed. So there'll be menstrual flow, blood, and tissue for about 3 to 5 days. By day 5, there'll be ovarian follicles being produced because the gonadotropins continue to rise during this phase and began acting on the ovaries again, causing more follicular growth. And the follicles can begin producing estrogen at about the secondary follicular stage from their granulosome cells. So we'll then move into the proliferative phase. So during the menstrual phase, menstruation occurs. During the proliferative phase, proliferation occurs. That proliferation is the rebuilding of the stratum functionalis. So we'll see glands enlarge and the spiral arteries increase in number to rebuild the stratum functionalis layer of the endometrium. So the rising estrogen levels are able to prompt this generation of the new endometrium. And normally we would see thick, sticky cervical mucus in the cervical canal, but during the proliferative phase, it actually thins in response to rising estrogen, because at the end of the proliferative phase, ovulation is going to occur. So that's why it's also called the pre-ovulatory phase. So ovulation occurs at the end of the proliferative phase or pre-ovulatory phase, and that thinning mucus will allow sperm passage. The secretory phase is going to be most constant time-wise. It matches up the luteal phase of the ovarian cycle. This is when the endometrium is preparing for the embryo. So we'll have a fully rebuilt functional layer. It'll have secretory mucus on it. Endometrial glands will be secreting nutrients ready for embedding its embryo. And there'll be formation of a cervical mucus plug in order to block any further sperm entry. If fertilization does not occur, all this prep kind of goes to waste. So the corpus luteum, which was making progesterone in the hopes that there was an embryo that embedded in the endometrium, degenerates, and all that progesterone that it's producing dies off, so progesterone levels fall. The spiral arteries that were proliferated and remade are going to kink and spasm and cause menstruation. The endometrial cells are going to begin to die, glands regress, spiral arteries relax, they open wide, and that rush of blood fragments from the weakened capillary beds and functional layer is just going to slough off. So menstruation is the result if fertilization does not occur. Here again, we can see fluctuation of ovarian hormone levels in the ovarian cycle. Now, these first 2 stages of the uterine cycle would occur during the same stage of the follicular phase in the ovarian cycle. And so during that phase, you have a low level, we'll say, of the ovarian hormones. It's not till mid-cycle that a rise in estrogen causes the LH surge, and then the LH surge causes ovulation. So after the follicular phase, which matches up with the menstrual and proliferative phase of the uterine cycle, is ovulation. And that's when we'll enter the luteal phase. And that's where we'll see estrogen drop a little bit until we have the corpus luteum producing a little bit more of it, so it'll slightly rise. But what we see as the most dramatic rise is the ovarian hormone production of progesterone, which rises and then falls tremendously during the luteal phase. So the corpus luteum produces progesterone. If there's no pregnancy, the corpus luteum degenerates, and that's why we're seeing here at the end of the luteal phase, progesterone levels die off. Here is an overview of the uterine cycle. Again, the 3 phases are the menstrual, proliferative, and secretory. The menstrual and proliferative match up with the follicular phase of the ovarian cycle. And the secretory phase of the uterine cycle matches up with the luteal phase of the ovarian cycle. We can see that the endometrium or functional layer is going to be the lowest during menstruation. Then it begins to grow back during the proliferative phase, and it'll be its thickest during the secretory phase, but then quickly drops back off during menstruation. So this is a cycle. So it will go back and forth. We would go menstrual, proliferative, secretory, and then go back to menstrual. After the proliferative phase, ovulation occurs. And we can see again, both the menstrual and proliferative phases occur before ovulation, and together they correspond to the follicular phase of the ovarian cycle, and the secretory phase corresponds in time to the luteal phase of the ovarian cycle. All right, the effects of estrogens include the promotion of oogenesis and follicular growth in the ovary. So we've seen that. It helped us create our mature vesicular follicle. So the production of estrogens from granulosa cells aided in the growth of follicular development. But they're also able to exert anabolic effects on the female reproductive tract and also support the rapid but short-lived growth spurt at puberty. We also know that they induce secondary sex characteristics, estrogens do. So the growth of breasts, the increased deposit of subcutaneous fat on the hips and in the breasts, and the widening and lightening of the pelvis, those are anabolic effects of estrogens, but also secondary sex characteristics associated with females. Other metabolic effects include maintaining low total blood cholesterol levels and high HDA levels in females, and facilitating calcium uptake. These are not true secondary sex characteristics. They're not functions necessarily only related to females, but they're things we do see because of estrogen secretion. Progesterone, however, is going to work with estrogen. It helps establish and regulate the uterine cycle. And then it also promotes changes in cervical mucus, which thins during mid-cycle and then thickens after the proliferative phase during the secretory phase of the uterine cycle. It also has effects on the placental progesterone during pregnancy. So progesterone is produced both by the corpus luteum and the placenta, and then kind of interfere with each other. It helps to inhibit uterine motility and prepare the breast for lactation. Next, we're going to talk about female sexual response, and we'll finish out Chapter 26, Part C.